Good morning. This is Molendinarius here from Latinum. You can find Latinum at Patreon. We're looking at Hawkins, an inquiry into the nature and principles of Thoroughbass on a new plan, published in 1817. And the lesson we're looking at today is going to be quite technical, perhaps a little bit boring. We're looking at the common chord and the various ways that it can be permutated, I suppose, or changed. So as Hawkins says, the common or perfect chord 3-5-8 will admit of the following changes: 2/3 and a fifth, one of those thirds backwards. So the first third is 3, the second third is backwards, and 5. So the backwards third is of course counting upwards, 1, 2, 3, 4, 5, 6, giving us 3, 5, 6. 3, 5, 6. But it's still conforming to harmony because it's composed of a third and a third and a fifth, just in different order. The second of these, 2/3 and a fifth. So the first third brings us to the third note, which is E in this case, because I'm starting from C. And then 1/3 backwards, giving us 6. And a fifth backwards, giving us 4 if we count forwards. So we have 3, 4, 6, this chord. The third chord we're looking at here is 2/3 and an eighth. One of those thirds is backwards. The first third is forwards. The second third is backwards, giving us 6. And we have, of course, 8. So 3, 6, 8. The next, 2/3 and an eighth, 1/3 backwards and an eighth backwards. If you count backwards an eighth, of course, you end up with your octave below. So we have 3, 6, 1. 6, of course, being the backward third, and 1 being the backward eighth, and 3 being our 3, as usual. The perfect chord can be changed with 2/5 and a third, one of those fifths backwards. So if you count backwards a fifth, you end up with 4 forwards. So we have 4, and then 5, which is our fifth, of course, and 3. So 5, 4, 3. The next example we're looking at is 2/5 and a third, 1/5 backwards and 1/3 backwards. Let's go backwards a fifth, which of course gives us 4 forwards. And let us go a third backwards, which of course gives us 6 forwards. And so we end up with 5, 4, 6. Right? 5, 4, 6. Two fifths and an eighth, 1/5 backwards. So counting back a fifth, 1, 2, 3, 4, 5. And this gives us, of course, 4, counting forwards. So we have 4, that's 4, and then the fifth, counting forwards, 1, 2, 3, 4, 5, 4, 5, and 8. next change of this ratio is 2/5 and an eighth. 1/5 backwards. Because if we count backwards a fifth from the top octave, we end up with 4 from the bottom. We have 5. And we have the eighth, which is the octave backwards. So we have 5, 4, 1. The next change, showing how the rules of harmony apply to the chord, is 2/8 and a third. One of those eighths is backwards. So the first eighth is here, the second eighth backwards is here, and the third, counting forward. So 8, 1, 3. Two eighths and a third, 1/8 backwards and 1/3 backwards. If you count backwards a third, of course, that will give us 1, 2, 3, 4, 5, 6. So if you see a 6, it's actually a third from the top octave. Or it could be 2/3 from the bottom, but we don't count that way. So we have 8, 1, and 6. Two eighths and a fifth. One of those eighths is backwards. So the first eighth, then our fifth, which is a regular fifth. So 8, 5, and then the backwards octave. 2/8 and a fifth, 1/8 backwards, and 1/5 backwards, which of course gives us 4 forwards, which we see here. So we have 8 and 4 and 1. The same method may be pursued as to the dissonant chord 3, 5, 7, only by substituting the seventh for the octave in all the examples above. Now, the reason why this exercise is useful is it shows you how the harmonies are constructed from thirds and fifths and octaves. In the harmony.